Hello everybody and welcome to another Mystery Box Function Challenge. In the purple mystery box we have some math and your challenge is to figure out what it is. You can use the link in the description to try this out on your own, and when you think you've got an idea, come on back and see if we get the same thing. Alright, I'm going to put in a 0. Okay, 0 gives us 0. How about a 1? Okay, just a little bit below that x-axis. How about a 2? Okay, kind of curving down. How about a 3? Oh, and 3 is giving us the infinity error. And most often we see that when we're dealing with rational equations, so I'll just jot that down over there. Let's keep going. Let's go with 4. And now we're above. I'm going to just look at some of the behavior really close to that 3. So let's do 2.5. And let's do 3.5. Yeah, so it looks like we've got an arm going up this way, and I'm guessing this is going to approach the x-axis as an asymptote as well. But we've got an asymptote right here at 3. So I think we're going to have an arm here and an arm over here. And let's just explore the negative side. Well, actually, let's go a little further on the positive side as well and watch and see if this does approach that x-axis as an asymptote. So let's put in a 5. And a 6. Okay, so definitely looks like that's approaching as an asymptote. Let's explore over here. You know, it does touch the axis here at 0. So what happens in the negative part? Huh, yeah, it's crossed that, and now it's going above. How about -2? And -3? Now we're getting another infinity error at -3. So that means we've got another asymptote here. So we've got I think this is a rational function with 2 vertical asymptotes. Interesting. Let's keep going a little bit. Let's do a -4 and a -5. So I think on the left it's going to approach the x-axis as an asymptote there. Let's do a -3.5. Right, and it's beginning to shoot down towards negative infinity there. And how about a -2.5? Okay, so what we've got here is 3 arms, and you can get 3 arms when you have a higher power on the bottom of your rational function. So we've got 1 arm here, and it approaches the x-axis as an asymptote, and then approaches this line x equals 3 as a vertical asymptote, and something, you know, sort of mirror image of that here, but down in the negatives, approaching negative infinity. And then you've got this middle thing that shoots up on the left and down on the right. So what could possibly be going on here? I think the place to start is with the vertical asymptotes. To get a vertical asymptote of 3 and -3, you'd have to have x squared, x squared plus, let's do the red color, x squared plus 9. Because if you put in a 3, that'd be not plus 9, minus 9. So if you put in a 3, 3 squared is 9, minus 9 would be 0. If you put in a -3 squared is also positive 9, minus 9 equals 0. So on the bottom, we've got x squared minus 9. I don't think this is just 1 over x squared minus 9, because we have to get 0 at 0. And the way to do that is to make the top 0. And if x is 0, we could just put x on the top. So let me rewrite this. That's gotten a little messy. So x over x squared minus 9. Now, that's what I'm thinking it is. That accounts for the 0.00 and the vertical asymptotes. Let's see if it works with some other points. So let's put in 2. So I'd have 2 over 2 squared minus 9. So that would be 2 over 4 minus 9. That would be 2 over negative 5. So that's negative 0.4, and that's what we got there. Beautiful. That seems to work. Let's try a positive. Well, actually, let's try a. The chart has gotten all messed up here, hasn't it? Let's try a positive 5 in this as well. So we've got 5 over 25. That's the 5 squared. Minus 9. 25 minus 9 is 16. So we've got 5/16, and that should be this 0.3125 that we're seeing right here. You can punch that in your calculator if you're not sure, but I think that's it. So I think we've got this, x over x squared minus 9. Let's go ahead and reveal. Yeah, that's what it is, x over x squared minus 9. Let's graph this thing. 3 arms, this sort of double up and down arm over here, and then the 2 arms that look a little bit more like the rational functions you're probably used to seeing on the left and the right. Well, how did that go? I think that was a tricky one. Let me know. Thanks, everybody.